Good morning. Welcome to Mission Control Houston and a live look inside the International Space Station Flight Control Room. This is where the Orbit 2 team of specialists now keeping watch over the space station systems, working with the space station crew members as they move through the second half of their workday on orbit. Right now, this team is working with just 3 crew members on board. Expedition 57 began early Thursday morning with European Space Agency astronaut Alex Gerst of Germany as commander, after half of the Expedition 56 crew got in their Soyuz vehicle and returned to Earth.
And touchdown. Ricky Arnold, Drew Feustel, and Oleg Artemyev back on planet Earth.
Welcome to Space to Ground. I'm Kayla LaFrance. This week, 3 members of Expedition 56 said goodbye. Cosmonaut Oleg Artemyev and NASA astronauts Drew Feustel and Ricky Arnold completed a 197-day mission spanning over 3,000 orbits of Earth and a journey of 83 million miles. Before their stay on board ended, Feustel handed over command of the station to crewmate Alexander Gerst from the European Space Agency.
Best of luck to you and your crew during your command of Expedition 57. May it prove to be both interesting and positively exciting.
Then the 2 crews said their farewells. The hatch was closed to the Soyuz spacecraft, and the returning crew undocked from the station's Poisk module. After the nearly 4-hour journey, the crew landed safely in Kazakhstan and was greeted by a recovery team who transported them to Karaganda. Feustel and Arnold boarded a NASA plane and flew back to Houston, while Artemyev returned to his home in Star City, Russia. Before disembarking, NASA astronaut Ricky Arnold wrapped up the Year of Education on Station, or YES initiative. And with a final call to students and educators, this real-time Earth to Space call allowed students to speak with an astronaut currently living and working on board the ISS.
Yeah, the science we do up here on the International Space Station has 2 purposes. It's to improve life on Earth, and for students sitting in classrooms, we're laying the groundwork for your exploration of the solar system, human exploration of the solar system.
Over the last year, YES enabled thousands of students and educators across the United States to speak directly with the crew in space. In addition, astronauts filmed new educational demonstrations, which will remain available to classrooms coast to coast. Check these out and see how you can continue to link up your classroom with the space station at nasa.gov/STEMOnStation. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
There was video in that report showing you some of the highlights of a crew return to Earth, but that's seen from the outside of the Soyuz vehicle. What's it look like for the departing crew members as they leave their home on orbit to return to the home planet? In 60 seconds, here's the insider's view of what that trip to Earth inside a Soyuz spacecraft looks like.
Welcome aboard the Soyuz MS spacecraft with non-stop service for Kazakhstan. Our flight time will be just under 3 hours 30 minutes. We'll be descending from an altitude of over 1,300,000 feet. At the time of departure, we're flying at a ground speed of 17,500 miles per hour. Please make sure all carry-on items are secured and that your seatbelt is correctly fastened. Now sit back, relax, and enjoy the flight. Ladies and gentlemen, we are now entering the upper levels of Earth's atmosphere. The estimated temperature outside is over 5,000 degrees Fahrenheit. During this zone of turbulence, we recommend you keep your seatbelt fastened while you're seated. As we start our final descent, our speed is down to 24 feet per second. At 1 second before touchdown, engines on the bottom of the vehicle will fire to soften the landing. On behalf of the entire crew, I'd like to thank you for flying with us. Welcome to Kazakhstan.
Alex Gerst, Sergei Prokopyev, and Serena Aunen-Chancellor won't be on the station by themselves for long. 2 new crewmates are targeted to join them in just a few days. And NASA TV and NASA.gov will have live coverage of their launch and docking. We begin that coverage next Thursday morning, October 11th at 2:30 a.m. Houston time, with Soyuz Commander Alexei Ovchinin and NASA astronaut Nick Hague already strapped into their seats on the launch pad at the Baikonur Cosmodrome in Kazakhstan. We'll replay highlights of their pre-launch activities as the countdown progresses and take it right through the targeted launch at 3:40 a.m. Central Time. And this will be a 4-orbit rendezvous profile, so we'll be back on the air and online with live coverage Thursday morning starting at 9 o'clock Houston time, with docking expected at 9:44. And then we'll return at 11:15 a.m. to cover hatch opening, and that should happen at 11:35 Central Time when the new members of the Expedition 57 crew float into the Poisk module. The NASA astronaut on board that Soyuz flight next week, Air Force Colonel Nick Hague, will be the first member of the astronaut class of 2013 to fly to space. But Hague would be quick to say that this flight, like everything else he's done in his life, is the result of a team effort.
I grew up in western Kansas, and I love figuring out how things work. When I was young, I liked breaking things and putting them back together. My entry into aviation started as a flight test engineer. I was an engineer working in a laboratory designing satellite systems and was accepted into the Air Force Test Pilot School. But I think that the amazing experience was just the breadth of airframes that I was able to explore and to test out. Everything from the most complicated fighters that we have out there to home-built aircraft. And that diversity of exposure really scratched my engineering itch to really get an understanding of what aviation's about. So my wife and I are both graduates of the Air Force Academy. The Air Force is the only way we would have ever met. My wife is from New York, I'm from Kansas. Our paths would have never crossed, so we owe everything to the Air Force and the Air Force Academy for bringing us together. We're both in service. We're both committed to serving our country. But more importantly, I think it's committed to serving something larger than ourselves. It's all about teamwork. Every assignment I've had, I've been part of a team. And that idea of you're going to be reliant on the people around you for success and defining your success not on your accomplishments, but on the team accomplishments, that's something that Air Force instilled in me and gave me the opportunity to grow and refine. Human space exploration is the ultimate team sport. We've got a team of 6 people on orbit. We're going to have a team of 5 people on orbit for my expeditions. We've got a team of over 100,000 people on the ground that are supporting us on a daily basis. You don't do these things individually. There's no success that's gained individually in space exploration. It's all about the team. I'm Colonel Nick Hague, and I'm a NASA astronaut.
A couple of minutes ago, Kayla mentioned the end of the year of education on station, which was designed to take advantage of the fact that we had a former classroom teacher on board to help students and their teachers here on Earth in their studies of science, technology, engineering, and math. It was an effort that was built on an example set by another teacher more than 30 years ago.
Reach for it. Presented by Science at NASA. In August 1984, President Ronald Reagan announced NASA's plan to send one of America's finest, a teacher, to space aboard Space Shuttle Challenger. Of 11,000 aspirants for the adventure, 37-year-old high school teacher Krista McAuliffe from Concord, New Hampshire, was chosen. As the first teacher traveling to space, she planned to conduct science demonstrations from low Earth orbit to get students, quote, excited about history, about the future, and about space, end quote. Tragically, Challenger broke apart soon after liftoff on January 28, 1986. There were no survivors, and McAuliffe's planned demonstrations were shelved. International Space Station astronauts Joe Acaba and Ricky Arnold have brought McAuliffe's mission full circle by completing and filming on orbit her envisioned lessons as a tribute to her legacy. U.S. crew members aboard the station have also performed and captured other brief, engaging lessons, or STEMonstrations. As part of the Year of Education on Station, NASA has made all of the demos available to classrooms around the world. Chromatography is one of the most interesting McAuliffe lessons Acaba and Arnold have brought to life. It provides hands-on activities for students to understand the importance of capillary action and chromatography and compare how they work in microgravity versus on Earth. Capillary action occurs anytime a liquid spontaneously flows into a narrow tube or porous material. It's how plants get water from their roots to their leaves. It's how our blood makes a round trip through our bodies. And it's how those paper towels soaked up the orange juice you spilled this morning. Chromatography is a technique that uses capillary action to separate mixtures so they can be analyzed. On Earth, chromatography is used for activities such as studying samples at a crime scene. Chromatography is an essential technique for spaceflight, too. For instance, keeping crew persons safe from contaminants includes analyzing unknowns, which can be critical on long space missions. An example of a Year of Education STEMonstration features NASA astronaut Randy Bresnik slingshotting objects of all sizes across the inside of the space station with a bungee cord. He's illustrating how Newton's second law of motion holds true in microgravity, just like on Earth. Simply put, Newton's law states that the greater the mass of an object, the more force it will take to accelerate it. Year of Education on Station also included more than 60 opportunities for hundreds of students and teachers to connect via in-flight education downlinks with astronauts aboard the space station for live question-and-answer sessions. Participants ask questions about all aspects of living and working in space.
Hi, my name is Ramsey, and my question is, have you ever had the idea to get a lot of water, pour it out, and see what happens?
See how it just sticks to my hand? It just waves there. It doesn't really go anywhere. It just sticks right to the surface, so I could drink my lemonade right from my hand.
How do you grow plants in microgravity without soil and water getting everywhere?
One of the plants actually uses pillows that are impregnated with moisture and the nutrients they need. We have another advanced plant habitat that I've been working on where there's a reservoir in the water. It's all very controlled, pretty much soil-free. The important thing is nutrients and water.
Hi, I'm Lexi. Would a yo-yo work in microgravity?
I didn't have a lot of time to practice, so here we go. My first yo-yo. So it works, but it's a little bit different. So thanks for the question and letting me find out if they do work.
With the Year of Education on Station, NASA's goal was to do what Krista and her optimism did so well: inspire students and teachers to, quote, reach for it, push yourself as far as you can, end quote. For more on NASA's Year of Education on Station, go to www.nasa.gov/STEMOnStation. For other inspiring NASA happenings, visit science.nasa.gov.
As you just saw, a part of the Year of Education on Station was the work of the station crew on a series of video features called STEMonstrations. Several NASA astronauts took advantage of microgravity to help students learn about a variety of scientific principles, like the short clip we saw of Randy Bresnik demonstrating Newton's second law of motion. Want to see the rest of it? Me too.
Hello everyone, I'm astronaut Randy Bresnik, living and working aboard the International Space Station. Now, on the space station, we live in a microgravity environment. Do you think the laws of physics will hold up? Come on, let's go find out.
The acceleration of an object depends on the net force acting on the object and the mass of the object, or F equals ma.
Surely good show, Sir Isaac.
Here we see that once the force of the thrust is greater than the weight of the vehicle, the rocket begins to accelerate.
All right, we're going to start with something small, something you might have at home, a little stick of chapstick. We'll go ahead and use our force, being our bungee cord here. We'll put it on our bungee, and we'll pull it back. And let it go. And you can see how fast it accelerates because there's very little mass. Next, we'll try a little spaceship. A little more massive, and you can feel that because as you move it, you can feel that the kind of the force, the extra force you have to push with your hand. So we'll put our spaceship on our launcher here, same spot. Notice it's flying a lot slower than that chapstick did. What we've seen is the same amount of force on a smaller, less massive object means the acceleration's faster. Well, this is the biggest and most massive thing we have, so let's see how the acceleration is affected. Pull back the same amount on the force, and here we go. And there you have it, Newton's second law of motion in action. Thanks everybody for exploring a little physics with me today. Now I'm going to send it back to Earth so you can start your experiments. See you again real soon.
An activity like demonstrations or the Year of Education on station are pretty high-profile ways that astronauts use their time in space to connect with people on Earth and share the experience. But resourceful astronauts have found other ways to connect their time in space to life on the planet. Recently, one station crew member who was watching a natural disaster on Earth unfold right below him found a way to help.
The first pictures now coming in from Puerto Rico after taking a direct hit. Hurricane Maria slamming into the island. One official saying the island is destroyed.
Hours with winds and rain and didn't stop.
Power lines are down. Streets are impassable. Many roads are flooded.
High winds uprooting trees, overturning cars, and turning buildings into piles of twisted metal.
It is something that will change Puerto Rico forever.
We had no water, no food, no gasoline, no communication at all.
Not knowing where my next meal will come from, it hasn't been easy.
After Hurricane Maria, everything was gray, all the plants were dead. Hurricane Maria took the color away from us.
I am sure that these children will not be the same. They will not be the same. They are still struggling and trying to recover from this.
My name is Joe Acaba. I'm a NASA astronaut of Puerto Rican descent. I was about a week into my mission on the International Space Station. Hurricane Maria was forming up, and from there, if you looked out the window, Maria took up a big chunk of what we could see. It was going to cover the entire island. After the hurricane, their power grid was pretty much taken out. You just couldn't see the island anymore. The hurricane, I think, had a huge impact on, the island as a whole, but especially the kids.
Joe Acaba was our hero, and we need something positive. The students need something positive.
We wanted to pull through, forget all that happened, and lift up our spirits and lift off the island.
So I knew I couldn't do much from up on the International Space Station, but I did want to connect with the students to show them that there is hope and that there are people out there that care about them.
NASA has the STEM station, which allows the students and teachers to talk to the astronaut in the space station.
It's making that connection so that maybe, they become more interested and we can inspire them more to study the STEM fields.
So we were able to establish and coordinate with NASA one of these video conference. Thousands of students from different parts of the island watching the video conference with the space station, talking to Joe.
This is Joe aboard the International Space Station. I have you loud and clear. How do you compare?
What is the most impressive view?
How did Puerto Rico look after Huracán?
Allowed to visit? What is the minimum number of?
It was awesome because, as soon as it came up, you could hear people clapping, people were excited. So even though I couldn't see them, I could feel them, and that was pretty neat.
It was amazing. He called from the International Space Station to see how Puerto Rico was doing, and that means a lot for us, a lot.
In May of 2018, I was able to go back to the island, my first time since the hurricane. It was a great opportunity to get out and kind of come full circle with those students, to go and see them in person and, kind of reiterate how important they are, and just to give them a little bit more hope, because there's still a long way to go on the island.
He's a hero for us. Kids love him, and everybody loves him here. Joe Acaba is the role model that we need at this time.
I want to be like him. I want to go far, and I want to be an example for little kids when I'm older.
Not only is the International Space Station a great tool for scientific research and exploration, but for students from Puerto Rico in particular, I think that having that video conference with them, it did provide some hope. It did provide some inspiration. And so it's just one of the benefits that we get from the International Space Station.
We're now in the midst of a crew exchange on the International Space Station. 3 crew members just departed in their Soyuz vehicle, and 2 more crew members are going to fly their Soyuz vehicle to the station next week. But the day is coming when people will make the trip to and from the space station in other vehicles. NASA's Commercial Crew Program is working with 2 companies that are moving right along in getting their rockets and space vehicles ready to join the fleet.
I am not a geeky person, and I don't really love software all the time, but actually seeing automated software, not only on the spacecraft, but on the rocket come together, it's really cool.
Boeing is flying a ULA Atlas V rocket, and they will have their CST-100, or the Starliner, as they call it, sitting on top of that. For the SpaceX side, we've got the Falcon 9 rocket, which is now the Block 5, and some of you may be hearing about that, as well as a modified Dragon capsule on top.
When you step into even just a demonstration of what their capsule looks like, it's like, whoa, this is huge. It has this beautiful feel and touch to it. It's very sleek.
We really designed, for the first time in 30 years, how does a human interface with a spacecraft? And a lot has happened in 30 years. I mean, we see cars that autonomously drive around the road. How do I create that interface to allow the human to be involved, but at the same time a passenger and not too involved? How do we make it easier for someone to become an astronaut?
Folks all over the world are going to be watching this because we're integrating new technology that's going to make these spacecraft better and smarter and paving the way for the future.
A tool that has helped guide sailors across oceans for centuries is being tested on board the International Space Station in an experiment looking at the use of a handheld sextant as a potential emergency navigation tool for guiding spacecraft across the cosmos.
astronaut lines up a known star and a prominent landmark, and feeding his readings into the computer, gets his position back from the machine.
John's pointing right now at the sextant and a telescope, which are our navigation means to get home.
No one knows the International Space Station better than the people who live and work there. They often take time to show off their home on orbit. During Expedition 52, the crew produced a series of bite-sized explanations of station components that they called Speedy Time, for reasons you'll see in a moment. Here, flight engineer Jack Fisher gives us a quick but thorough tour of payload activities inside and outside the airlock in the station's Japanese laboratory module, Kibo.
Everybody, I'm going to do my best over the next few months to show you in bite-sized chunks this wonderful place I get to call home. I'm going to have to talk fast, so we're going to call it Speedy Time. All right, the first one is the gym airlock. This is so cool. It has a slide table. We open it up, the slide table comes out, we can put all sorts of things on it, put it back in, depressurize it, because it's an airlock, and then slide it outside. We have a robotic arm. We can control it with this wonderful panel here, or they can control it from the ground. How cool. And then, once it's outside, we put all sorts of experiments out there. Let's take a look, because it's gorgeous. This is the gym window. Woo! And there are some of the experiments, including the robotic arm, which then controls all of those experiments once they're outside and puts them in the right position. Or, in the case of small satellites, it actually launches them. How cool is that? That is your first Speedy Time video. Have a great day. See you next time.
If you'd like to get another look at any of these stories we featured today, check us out on YouTube and on Facebook. There are the addresses in the blue box. While you're at those spots, check out all the other cool stuff you can find about NASA and America's human spaceflight program. You should also check out Houston, We Have a Podcast, which features folks here at NASA talking about their work in all aspects of space exploration. We post new episodes every Friday, and today, October 5th, Gary Jordan talks with Nick Hague, the next American astronaut bound for the International Space Station. He's going to launch from Kazakhstan on Thursday, October 11th. Go to www.nasa.gov/Johnson/HWHAP, Houston We Have a Podcast. You can go there anytime to find all of the episodes. You can also listen to them all on Apple Podcasts, Google Play, and SoundCloud. This is Mission Control, Houston.